ক্লাস 10-এর ছাত্রছাত্রীরা তোমাদের ওই কারেন্ট ইলেকট্রিসিটি চ্যাপ্টারের ওপর থেকে আমি পড়াচ্ছিলাম। তো মোটামুটি যে জায়গাটায় আমরা ছিলাম সেটা হচ্ছে ওহমস ল ছিলাম, ইএমএফ, ইন্টারনাল রেজিস্ট্যান্স হয়ে গেছে, resistivity and conductivity is over, semiconductor and superconductor it's over. Now we are going to study the combination of resistance. So actually there are, if we need any specific resistance that is not available in market, then I have to make these resistance by some combination. So I have to I have to know the ways of combination. So the combination of resistance, combination, combination of resistances. They are basically in two types. One is series and another is parallel. So series combination and parallel combinations. There are two types of combination of resistance, and we have to find out the equivalent resistance from each series of combination, each combination of resistances. So first of all we are going to study the series combination of resistance. So let us consider three resistances are connected in that way as I have drawn, okay, one after another. The resistance in such a way the resistance are connected are said to be the series combination, that one resistance after another resistance, after that another resistance, or so forth. N numbers of resistance can be there, but they should be connected in that way, and that is called the series combination of resistance. Okay, now we are giving some name of them, R1, R2 and R3. Okay, very simple. And we are getting some nodes between two resistances so that it could be simple, or it could be easy to calculate some calculations. Let the terminal is A and another terminal is B, and here some nodes C and D, and we consider the current is flowing through the series combination is I. So we consider more things, that is the potential at the terminal A is VA, VC, VD and VB, because for each and every resistance there is potential drop. The potential at that point A is higher than the potential at point C, which is higher than the potential at point D, and definitely the potential at point B will be the least from this drawing, from this circuit. So there is each and every resistance due to which there is potential drop. Okay, now I am going to write something. For example, okay, so in case of the first resistance, VA minus VC is a potential difference equals to Ri into I. R1, sorry, it is not Ri, it is R1I. So this is the first equation we have from this first resistance. Again, Vc minus Vd equals to R2I. This is second equation. And after that, Vb minus Vb equals to R3I. This is number 3 equation. Now, let us consider that these three resistances are replaced by single resistance. So what should be its value? Then the combination or the equivalent resistance, the question of equivalent resistance arises. Therefore, we consider one resistance instead of three resistances, and this terminal is A and this is B, we are thinking, let us consider the equivalent resistance is R. Now the current is moving from A to B, and that is I. So the potential is VA and it is VB. So according to the drawing of this equivalent resistance, what we can write, that VA minus VB equals to R into I. Okay, this is number 4 equation. Now if we add these three equations, then what we have? If we add these three equations, so we have VA minus VC plus VC minus VD plus VD minus VB equals to R1I plus R2I plus R3I. Okay. Now VC, VD, they are all cancelling out. So we have VA minus VB equals to I common, that is R1 plus R2 plus R3. Okay, there is no problem. So this is another equation. We can say this is equation number 5, and we have VA minus VB RI from equation 4. So we are solving or equating equation 5 equals to equation 4. We have RI equals to I R1 plus R2 plus R3. So we have the equivalent resistance is equals to R1 plus R2 plus R3. So it is very clear that when the resistances are in series combination, to get the equivalent resistance from it, the value of each resistance are added together to get the equivalent resistance. It is very important formula that we have to use for simplification of mathematical problem, to crack or solve the mathematical problem on it. And there are so many basically there are so many small things related to series combination of resistance are associated. That is, if we consider each and every resistance are equal, therefore R1 equals to R2 equals to R3, we consider it is small r. Then what should be the equivalent resistance when they are connected in series? So we have the formula, that is R equals to R1 plus R2 plus R3. So we can write R plus R plus R, that is 3R. Simply in series combination, when we are using equal resistance in series combination, the equivalent resistance will be 3 times of any one resistance. Therefore we can write that this one R equals to 3R. By the same way, if we consider there are n numbers of resistances, n numbers means a huge number of resistance, it is finite number definitely. For generalization, we can say n numbers of resistance are there. Definitely. Okay, if there are n numbers of resistances are connected in series, then the equivalent resistance will be R equals to NR. Okay, if R be the resistances of each, the value of the resistance of each series, and the number of resistance are used in numbers of resistance, then the equivalent resistance will be NR. Okay. Now we are going to talk about the parallel combination. So we have to talk about parallel combination. So what is the circuit of parallel combination? In parallel combination, three resistances are connected in parallel. They are parallelly connected. Now the potential is VA and VB. The current is I. A part of that current I1 is passing through resistance R1. I2 is passing through resistance R2, and I3 is passing through resistance R3. Now, if I write VA minus VB equals to I1 R1, this is number one equation. Second equation, VA minus VB equals to I2 R2, number two equation, and VA minus VB equals to I3 R3, number three equation. Instead of these three resistances, if I use single resistance, then the drawing would be like that. This is A, this is B, VA, VB, and I with the current. Therefore, VA minus VB equals to RI. That we know. So we can do one thing, that we know that I equals to I1 plus I2 plus I3, because these I is divided in three parts. We don't know what are the exact value or the partition value. I1, I2, I3 putting together, it is getting again I. So I can do one thing, I1 equals to VA minus VB by R1. We are getting fourth equation. I2 equals to VA minus VB by R2. This is fifth equation. And I3 equals to VA minus VB by R3. Sixth equation. Now, if I add I1 plus I2 plus I3 equals to VA minus VB, if it is common, then I have 1 by R1 plus 1 by R2 plus 1 by R3. Now, these I1, I2, I3 and VA minus VB, actually I2, I1, I3 equals to I. That is VA minus VB, and the remaining part 1 by R1 plus 1 by R2 plus 1 by R3. Now, if I do this thing, VA minus VB by I equals to R. That means 1 by R equals to I by VA minus VB. So I can do one thing, that these VA minus VB will come down. So I by VA minus VB equals to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, I have to shift this camera a little bit down. Now, these I by VA minus VB equals to 1 by R1. Therefore, my ink is getting fed. So, 1 by R equals to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So, 1 by R equals to 1 by R1 plus 1 by R2 plus 1 by R3. If each and every resistance have the same value, then I can write that R1 equals to R2 equals to R3 equals to R, or I can write small r. Then 1 by R will be 1 by smaller plus 1 by smaller plus 1 by smaller, that means 3 by smaller. That means R will be R by 3. So if we take three resistances of equal value and if they are connected in parallel, then their equivalent resistance will be 1/3. By the same way, if we connect n numbers of equal resistance in parallel combination, then the equivalent resistance will be R equals to R by N. So, if we take a large number of equal resistances and connected them in parallel combination, then the equivalent resistance will be less. Okay, and very simply, the equivalent resistance of parallel combination is always less than each and every resistance of that parallel connection. That means these are equivalent resistance will be less than R1 separately, R2 separately, and R3 separately. That means individually the value of the equivalent resistance is less than each and every resistances. That is the main thing. And if they are connected in n numbers of resistance, the value will change to, or the formula is like that. Okay, today is, I think today is enough for that, and we will meet again in our school from day after tomorrow. Okay, up to then, take care of yourself.